In this video, we're going to go over some practice problems for chapter 3 of the textbook where we're applying the perfectly competitive market model. So our first one, we're going to look at just sort of basic equilibrium, solving for equilibrium, and identifying the distribution of surplus, meaning the distribution of consumer and producer surplus. Then we'll look at a problem applying quotas, followed by a problem with a price floor and a subsidy. And then our last problem will have a price ceiling and a tax. Okay, so for our first problem here, we're going to be looking at the market for noni. Noni is a tropical fruit that grows on the Pacific Islands. And we're going to describe this market using the demand function quantity demanded equal to 40 minus 10 times the price. And supply will be given by quantity supplied equal to 20 times the price minus 20. Okay. And again, this is the market for noni. I'm going to go ahead and draw the market here so that we have a graph that we're working with for this problem. So this is the market noni. Okay. Looking at my supply equation, I can see that the supply curve is going to have a positive value for its vertical intercept, and same for demand. So let's go ahead and find the supply choke price and the demand choke price so we can graph our supply and demand curves here. So starting with supply, to find that supply choke price, we're going to solve for the price. We're going to solve for that inverse supply equation. So I'm going to start by adding 20 to both sides. So we'll have Q plus 20 equal to 20 times the price. Then we're going to divide both sides by 20. So we'll have quantity over 20 plus 1 equal to the price. All right, so for our supply choke price, that's whatever the price is when quantity is 0. So substituting 0 for quantity, we'll get 0 over 20 plus 1 equal to the price. So that supply choke price is equal to 1. Okay. Now we're going to do the same for demand. So we're going to start by adding 10 times the price to both sides. So we'll get quantity plus 10 times the price equal to 40. Then we're going to subtract quantity from both sides. So we get 10 times the price equal to 40 minus quantity. Then we'll divide both sides by 10. So we'll get price equal to 4 minus quantity over 10. Again, that demand choke price is where the price that has quantity demanded equal to 0, right? The price at which consumers want to buy nothing. So we'll substitute 0 for quantity, and that's going to give us price equal to 4 minus 0 over 10. 0 over 10 goes to 0, so that choke price is going to be 4. So we can draw those in. All right. Next, for our demand equation, we want to know what the quantity intercept is. So for that, we're just going to substitute 0 for price. So we'll have quantity equal to 40 minus 10 times the price, which for our horizontal intercept, we want it equal to 0. So quantity is equal to 40, and then 10 times 0 goes to 0. So that quantity intercept is going to be 40 for our demand curve. And with those 2 points, we can draw in our demand curve. Okay. All right, we're going to wait to draw in our supply curve until we have our equilibrium quantity. Okay. So let's go to solving for that equilibrium quantity next. So we will have, let's see, quantity supplied equal to quantity demanded in equilibrium. Quantity supplied is equal to 20 times the price minus 20, and quantity demanded is equal to 40 minus 10 times the price. Here we're going to solve for the price. So we will add 10 times the price to both sides. That's going to give us 30 times the price minus 20 equal to 40. Then we'll add 20 to both sides. That gives us 30 times the price equal to 60. And then when we divide both sides by 30, that's going to get us a price in equilibrium equal to $2. Okay. So we know that our equilibrium price is going to be $2. Now we need to find that equilibrium quantity. So first solving for quantity supplied, that's going to equal 20 times the price, which we found to be $2, minus 20. So that gives us 40 minus 20 equal to quantity supplied. So quantity supplied is going to equal 20 at $2. Let's do the same for quantity demanded. That's going to be equal to 40 minus 10 times the price, which we found to be 2. Simplifying, we get 40 minus 20, which is going to leave us with quantity demanded equal to 20. So that equilibrium quantity is 20. In this case, quantity is measured in thousands of pounds. So our equilibrium quantity is actually 20,000, but since we're noting that quantity is measured in thousands, we're just going to write 20 for that point on our quantity axis. All right, now with these 2 points, whoops, sorry about that. Now with these 2 points, we can draw in our supply curve, right? And we have our basics for our market for Noni graph. Now we just want to identify the distribution of surplus. So this top triangle here is going to be consumer surplus. Let's go ahead and note that in another color. Let's use blue. So we'll have consumer surplus is blue here, that blue triangle. And producer surplus is going to be this green triangle. Okay. So that's the first part of our problem, is to draw that market for Noni. Part B asks us to calculate the consumer surplus available in the market. So that's going to be that area that I've represented in blue. And it's a triangle, so we're going to use the area for a triangle. Right, so this is part B. So remember that area of a triangle is 1/2 base times height. So we're going to have consumer surplus equal to 1/2 times the base. And the base is going to be the amount exchanged. So that is 20. So 20 minus 0. So we'll have 1/2 times 20 minus 0. And then our height is going to be the height of our blue triangle on the price axis. So that'll be 4 minus $2, that demand choke price, minus the equilibrium price. So 4 minus $2. And then we'll simplify. So we'll have consumer surplus equal to 1/2 times 20 minus 0 is 20 times 4 minus 2 is 2. That's going to get us 1/2 times 40. And then half of 40 is 20. And then remember that our quantity is measured in thousands. So we want to multiply that final answer by 1,000. And that gets us that consumer surplus in this equilibrium graph is $20,000. All right. Part C asks us to find producer surplus, which we identified in using that green pen. So it's that green triangle here. And again, since it's a triangle, we're going to use that same formula, that 1/2 base times height. So we'll have producer surplus equal to 1/2 times our base, which is just the quantity traded. So it's also 20 minus 0. And then our height is going to be shown on that price axis. So $2, that equilibrium price, minus 1, our supply choke price. Okay. And then from there, we're going to simplify. So we'll have producer surplus equal to 1/2 times 20 minus 0 gives us 20. 2 minus 1 gives us 1. So we have 1/2 of 20, which is 10. And remember, quantity is measured in thousands. So we're just going to multiply this final answer by 1,000. And that gets us that producer surplus is equal to 10,000. All right. Part D asks us to calculate the total surplus available in the market. And total surplus is just consumer surplus plus producer surplus. So total surplus, that's going to be consumer surplus. Here, let's see, let's change the color. Did it work? Nope, let's try again. Okay, so we're going to add consumer surplus and producer surplus to find the total surplus. Okay. So total surplus, I'm going to abbreviate with TS. That's going to equal our consumer surplus, which was $20,000, and plus our producer surplus, which was $10,000. So that means that our total surplus then is $30,000. $10,000. Okay, so we can use this as a guide, right? If we were to say, look at a price control placed on this market, or as we'll turn to next, a quota. The distribution of surplus at the end of that application of the intervention should end up to this same value. And in that case, with the intervention, it'll be consumer surplus plus producer surplus plus deadweight loss. All right, so total surplus is all of the potential surplus available. Okay, so just keep that in mind. It's a good way to check yourself to make sure you've done your calculations correctly. All right, so we're going to say, suppose the USDA and FDA decide to place a quota on NANI at 10,000 pounds, and we want to find what the market price would be with this quota. So we're going to go back up to our graph and draw in that quota at 10,000 pounds. Okay, so here's our 10. I'm just going to mark this using red here. So our supply curve is actually going to kink with our quota such that it's perfectly inelastic at 10,000 pounds of NANI. And in order to find the price with that quota, what we're going to do is we're going to substitute for that 10,000 in our demand equation. I believe it was 40 minus 10 times the price. Yep. And solve for whatever price that is. Okay. So what we're going to do here is first add 10 times the price to both sides. That's going to get us 10 times the price plus 10 equal to 40. Then we'll subtract 10 from both sides. That'll give us 10 times the price equal to 30. Divide both sides by 10. And that gives us a price of $3 when a quota of 10,000 pounds is enforced. That's part D, or excuse me, part E. Next, part F asks us to identify the distribution of surplus under the quota. So let's look at what our surplus looks like post the quota. So after the quota, what we're going to see is that there will be some of what was previously consumer surplus transferred to producers, as well as some dead weight loss. Okay, so now we have producer surplus equal to this trapezoidal figure. Okay, oh, let me draw back in that quota. There we go. Okay, so our producer surplus is now this trapezoid. And we're going to eventually break it down into a rectangle and a triangle for ease of calculation. And our consumer surplus is this much smaller triangle above that quota price at $3. And we actually now have producer surplus, excuse me, not producer surplus, deadweight loss in this market. Right now, there are 10,000 pounds of noni that is no longer being bought and sold. Let's try drawing that in. Okay, here we go. All right, so that's the deadweight loss. So we need to find the consumer surplus, the producer surplus, and the deadweight loss. All right, so let's start with consumer surplus. So again, we're going to solve for using that area of a triangle formula. So consumer surplus here, we'll have 1/2 times the base. Now only 10,000 pounds are being traded. So our new base is 10 minus 0. And the height is the demand choke price minus the new price, which is 3. So simplifying, we have consumer surplus equal to 1/2 times 10 times 1. Half of 10 is 5. And then our quantity is again measured in thousands. So we want to multiply that final value by 1,000. And that gives us our consumer surplus, which is now 5,000. And it's fallen from 20,000. So consumer surplus has fallen a lot as a result of this quota. Producer surplus here is now a rectangle plus a triangle. All right, so in order to find producer surplus, we're going to add the area of our triangle to the area of our, the area of our rectangle to the area of our triangle. All right, but to find the triangle, we need to find the price at which producers are willing to provide 10,000 pounds of noni. Okay, so we're going to take our supply equation, and we're going to substitute 10,000 in. So we'll have 10,000 equal to 20 times the price minus 20. Okay. And then we're just going to solve for that price. So first we'll add 20 to both sides. So we'll get 30 equal to 20 times the price. Then we'll divide both sides by 20. That's going to give us 3/2 equal to the price. And of course, 3/2 is just equal to $1.50. All right, so that is the price at which producers will provide 10,000 pounds. So we've not yet found our producer surplus yet, but we have now all the information we need to do so. So let's first find that area of that triangle. So for our triangle here, producer surplus, it's going to be 1/2 times the base, which is that 10,000 sold, times our height, which is $1.50 minus the supply choke price of $1. And then we're going to add the area of our rectangle. And if you remember, you can find the area of a rectangle just by multiplying length times width. So we're going to multiply our side of our triangle here formed by the price axis. So 3 minus 1.5, and then multiply that by 10. So we'll have 3 minus 1.5 times 10 minus 0. Okay, and from here we'll just simplify. So producer surplus is equal to 1/2 times 10 times 0.5 plus 1.5 times 10. Okay, so that gives us 1/2 times 5 plus 15. So 1/2 times 5 is going to give us 2.5 plus 15. So that equals 17.5. And then remember that quantity is measured in thousands. So we're actually going to multiply this 7.5 times 1,000. So that gives us 17,500 for our producer surplus. Okay. And now the last value we need to find here for our distribution of surplus is the deadweight loss. The deadweight loss is a triangle. If we go back to our graph here. So we're going to use that area of a graph formula again. But now our base is the difference between what is exchanged in equilibrium and the amount exchanged under the quota. Okay, so that's our base. So we'll have 20 minus 10. And then our height is the difference between the price at which suppliers provide 10,000 pounds of nani, which is $1.50, and the new price at the quota, which is $3. So we'll have a height of 3 minus 1.5. Okay, so our deadweight loss, we're going to have 1/2 times 20 minus 10 times 3 minus 1.5. Simplifying, that gets us 1/2 times 10 times 1.5, which simplifying again gets us 1/2 times 15. Half of 15 is 7.5. And then again, remember our quantity variable is measured in thousand, so we multiply that value by 1,000, and we get that our deadweight loss is equal to $7,500. Okay, so what I would want to do now to check myself to make sure I've done all these calculations correctly is make sure that the total surplus is still 30,000. So we're going to have consumer surplus plus producer surplus plus deadweight loss, and that should equal 30,000. Okay, so let's see. So our deadweight loss, we have is 7,500. Producer surplus is 17,500, and producer surplus is 5,000. Okay, so total surplus is equal to 5,000 plus 17,500 plus 7,500. Okay, so 5,000 plus 17,500 is going to get us total surplus of 22, let's see, yeah, 22,500. And we're going to add to that 7,500. So 7,500 plus 22,500 is indeed going to get us $30,000. So we've done all our calculations correctly, and we've identified that distribution of surplus in the market for nani when there is a quota. Okay, that is practice problem number 1. Next, we're going to move to practice problem number 2, and we'll do that in the next video.